buddy. Here, I'm going to start my recording up here, just real quick here. Then we'll be on our way. Uh, okay. Um, and OBS, I'll start that recording too. Okay. Uh, Here we are. We have our special guests for the first Wow Signal Live. I guess I'd apologize in advance that we don't really know what we're doing here with the live thing, so uh, just bear with us. But the hold on a second here. Uh, but anyway, we are honored to have with us the director of the American. Uh, is it the American Amateur Variable Star Observers? Is that right?
No, it's American Association of Variable Star
American
Observers.
Association of Variable Star Observers.
There you go.
Director Stella Kafka from Cambridge, Massachusetts, and also joining me today is Chiro Villa from Florida,
Hi, Paul.
and say hello, Chiro.
Yeah, hi, Paul. Can you hear me?
Yeah, I can hear you.
Uh,
And Daniela DePaulus, who's frequently a co-host on this podcast.
Hi, Paul. How everyone?
And so uh, I thought it'd be great to have Dr. Kafka on to talk about some of the interesting variable stars that have been in the sky lately. The big one in the news has been Betelgeuse, so we're certainly going to get to that. But and the organization she directs has been observing a lot of these interesting stars and reporting their magnitudes and so on. And we'll have her kind of explain how that works for a more general audience as well. And then we'll take any questions. Now, we're taking questions on Discord and on Twitter. If you go to @PodcastWow, you will see pinned to the top of our profile the link to Discord where you can go in and type in your question. And I'm monitoring that right now live. So if you have a question, I'll see it and I'll relay it to Stella, and we'll have a chat about that. And also, of course, any questions that Chiro and Daniela have. So so let's start with the basics. Stella, tell our audience kind of what your organization does and kind of how it works a little bit at a very simple level.
Absolutely. Good morning, everyone. It's actually a pleasure to be back, Paul, and talk to your audience again. It's also a very exciting time for the AVSO because of Betelgeuse, which is the star of the season, apparently. So let me start by telling you reminding you actually that the AVSO was formed in 1911 from the Harvard Observatory, when the then director of the Harvard Observatory gathered a group of amateur astronomers in order to take data for his project. So in essence, we are the first amateur professional citizen science collaboration that was formed exactly in order to do science, in order to help professional astronomers with their scientific projects. Since then, we have grown. It says American in the name. We are an international organization. We have members and observers from 56 different countries in the world. We have individuals who are sending us data or asking for data from all those countries. We are a group of about 5,000 individuals all over the world who are interested in understanding some aspects of stellar variability. Just reminding you that variable stars are stars whose brightness is changing in the night sky within timescales that we can observe from the Earth. And these are stars that we can actually assess that are changing with means that we have, such as our eyes or binoculars or looking through an eyepiece of a telescope or even a DSLR camera or a CCD camera in a telescope. So all means are being used in order to actually acquire data on these stars. Now, the very core of our program are databases, one of which is the photometry database that has data from more than a century on about 30,000 objects, variable objects, including exoplanets, including some of active galactic nuclei, which technically are black holes, stellar remnants that are eating up everything around them. And pretty much anything and everything that you can imagine, from the brightest stars in the night sky to as faint as 17 magnitudes. And that's a different discussion, how we actually select our targets. But as you mentioned, right now, what is stealing the show is a star that we are all familiar with, and we can see from the north and the southern hemisphere. And it's been known to be up there and be variable for thousands of years, and recorded to be variable in the AVSO database for at least 130 years. And that's Betelgeuse, Alpha Orionis.
Yeah, that's I've always found that a really easy star to find in the sky because it's so bright, it's so red.
Yes.
And of course, Orion is the constellation almost anyone can recognize.
Yes. Yeah, it's a big hunter, right?
Yeah, with the three stars in the belt, and then the red star and the blue white star on either side of it. That is now. What's going on with Betelgeuse? Have you? I know you guys have been watching it almost every night.
Yes, what's going on with Betelgeuse? Who knows what's going on with Betelgeuse? Just joking. So, as I said, we have about 130 years of data of Betelgeuse. So, we have been observing this star for a long, long time. Since it's one of the brightest in the night sky, the first observations were visual. People were looking at it with their own eyes. And we know, if not anything else, that Betelgeuse is what we call a semi-regular variable star. So, this is something that is showing some periodicity, but it's interrupted with irregularities. So it is not exactly a periodic star. It's not a star that is doing the same thing again and again and again in a very regular way. So far, analysis of that data has showcased that Betelgeuse has what we call a cycle, about 6-year cycle. So every 6 years it brightens and it fades. But superimposed to that cycle, there is another cycle that is about 430 days long, that is doing its own thing. And these cycles are because of the growth and fainting of big spots. Just imagine star spots, sunspots. But similar, but not quite the same phenomena, and much, much larger in extent on the surface of the star. So it has to do something with the convective cells on the surface of Betelgeuse, like the integrated convective cells. So we know that Betelgeuse is going bright and fade, right? We know that it's dimming from time to time. We know that its brightness is not exactly constant. What's special about this particular fading is that this is the faintest we've ever observed it in our recorded history. Does this make sense?
Yeah.
So suddenly dim.
For about 100 years, in other words. Yeah.
For about a recorded history, right? So at least when we're looking at our light curves, we're looking at our data. So we know that it can dim, and when it started dimming, yeah, sure, Betelgeuse is dimming, and then it kept dimming, and it kept dimming, and kept dimming. It's like, whoa, hold on, what's going on with Betelgeuse here? And this is where it became the star of the season. This is where everybody got really excited, as in, this is a star that everybody can see, even from downtown Boston. It's kind of one of the most light polluted cities that I know. And still, if you're paying attention, you're very familiar with it, you can see it being not so bright anymore with respect to other stars in the constellation. Yeah. It's like our experience that makes it exciting.
Yeah. Now, astronomers do believe that someday, they don't know exactly when, Betelgeuse is going to go supernova, right, and become extremely bright.
So we know when. It's within the next couple of thousands, hundreds of thousands of years.
Oh, okay. I'll put it on my calendar.
I know, right?
Yeah, soon, in an astronomical sense, right? But not in a human sense. So yeah, we don't. The current dimming may have nothing to do with that, right?
Exactly. So there are no models that give any indication that a dimming of a star of that mass and that radius and that stellar evolution stage is connected with it becoming supernova.
Right. I understand.
These are two things that are sort of separate. Now, having said that, our models for this type of stellar evolution are very hand-wavy. They're very vague. Remember, models are being driven by observations, and we have not observed the behavior of a star right before it became a supernova type 2 in such detail to fit in our models. But there is no physical reason why this star should, a star of this kind of brightness and this kind of mass, should dim before it goes kaboom. I mean, dim in the visual magnitudes, and at least with the rate that we see in Betelgeuse.
Oh, okay. But you guys are keeping an eye on it just in case, right?
Oh, we're certainly keeping an eye. You know, if it goes, or when it goes supernova, we will all keep an eye on it. It will get brighter than the full moon in the night sky. It's going to be
Paul,
gorgeous.
you allow me for quick question for Stella. Is there any other possible, I don't know, phenomenon explanation for something like this to occur other than the intrinsic variability of the star itself? Could there be an extrinsic explanation in this case, in the case of Betelgeuse?
Extrinsic as in another object?
Well, yeah, like some sort of obfuscation happening, some sort.
So the leading theory that has been proposed by a group from Villanova University and colleagues is that pretty much, remember I told you that it has a 5.9 year or 6 year cycle, right? And then it has a 430-day cycle. Somehow those cycles coincided.
Mm-hmm.
So as a result, the first cycle, you see a dimming every 6 years, right? As a result, the second cycle, you see a dimming every 430 days. Now, if you put them both together, then you see a dim and a dimmer sort of phenomenon. So that is the leading theory right now. Having said that, in order to confirm that theory, we need to actually see that phenomenon being completed, recovering, and we need to see how it behaves over the next several years. So this is something TBD. Right?
You have a complete picture yet.
There you go.
Cannot complete the curve.
There you go. And that is why it's really very valuable to keep collecting data on this object. Now, the reason actually why we notice that something like that is happening is because we already have data on this star. Right? How many other stars similar to Betelgeuse might be showing this kind of behavior, but no one has data on them? So Betelgeuse can be actually the prototype of feeding into models of similar stars that would give us more information of how these stars evolve, how these stars progress during a very interesting phase of their lives, just a couple of hundred of thousands of years before they become supernova, right? Which is just because.
It's fascinating. I mean, it's obviously fascinating to witness, if nothing else. Something even, I guess it's interesting to see all the speculation of the community out there. It's kind of interesting in itself.
Well, the headline writers always want to put in something
That's
like,
right. Exploding tomorrow.
Star may explode.
Exploded
well,
tomorrow.
Of course, supernovas go off every day. They're too far away to be visible to the human eye. But.
What do you think this possibility that it exploded is generating so much interest, not only amongst astronomers, but also amongst the general public? I've seen a really active and very colorful conversation about this topic on the SETI community mailing list.
You said why?
Yes. Why do you think it's generating so much cultural interest?
I think that it has to do with the fact that we are witnessing something right now, something that we can see with our own eyes. In astronomy, as human beings, we are explorers, right? We explore nature around us. We try to figure out how things work. We love it when we find out how things work. We love it when they do something bizarre, and we love it when they do something extraordinary. Think volcanoes going kaboom, right? We love when the catastrophe like this is happening, human ramifications aside. With the universe, it's a little bit different. We get excited when we hear about the cosmic explosion. We get excited when we hear about detection of, neutron star mergers, gravitational waves. But this is not exactly part of our everyday experience. It's not something that you or I can look at and say, oh, look, something happened, it changed. Betelgeuse is different because Betelgeuse is just 700 light years away. It's in our neighborhood. And Betelgeuse is a star that we know. This is a red star in the big hunter Orion, right? And even if you take the simple kind of astronomy class, you will learn the constellations, and Orion is one of the most prominent and easier to identify even from a city center. So at some point, it triggers people's imagination when you see this red star and somebody tells you that within the near future, quote unquote, astronomical future, it will go supernova. So you and I and everybody will get to witness a supernova. And I really wish it was supernova, darn it, because I've never seen one of those. But it's one of those things, it's experiential. It's more of something that we as common human beings, without having any special detectors or access to sophisticated equipment, could eventually be able to witness. And I think that this is one of the things that triggers people's imagination. There's also the wow factor. Think about how people are intrigued and amazed by a solar eclipse. It can be a very emotional experience for some. It can be a very exciting experience for others. Or a lunar eclipse. You see the moon being covered in the blood moon, right? It's so invigorating in a way. The difference with this kind of phenomena is that we can predict them. So when it comes to supernova eruption, within a couple of hundreds of thousands of years, which kind of blows our minds in their little kind of 100-year lifespan, right? And if somebody tells you, oh, it's happening anytime now, quote unquote, within cosmic timescales, you wish you would witness it. It's something that no one has ever seen before, right?
Yeah, this idea of a real time suddenly extends to a 700-year time span. That's pretty interesting.
Yeah, so, well, real time, again, in astronomy, we're looking at the past, right? So whatever we're looking at Betelgeuse right now has happened 700 years ago. Yeah.
Is it known if does Betelgeuse has any planet? Is this known by the astronomical community?
It's not known. We don't really know that. We know that Betelgeuse has not had any detected companions. We don't know of any detected companions, planets or smaller stars or anything else.
Yeah, they could be there. We just haven't detected them.
Yeah, although Betelgeuse is a supergiant, right? And it's a massive star, so evolved really fast. So if it had any planets nearby, the initial object, the object that became the giant, then they're completely swallowed. And then if it has planets further out, more power to them. I don't know. They're going to witness a supernova in a much more dramatic.
Right. It's really not that old a star. It's actually a fairly young star.
It's about 8 million years old. So.
Yeah. Which compared to the sun is a baby.
Oh, yeah. It's a baby. Yeah.
Yeah.
So massive, the lifespan is short. The bigger they are, right?
Yeah.
I believe.
Right.
The shorter the lifespan.
Correct. So they're like cars. The bigger cars consume their fuel much faster than my little Beetle.
So will how we look at it, will that change if Betelgeuse became a supernova?
Oh, yes. Oh, my goodness. There are some... this is what I'm saying, it triggered a lot of people's imagination. There are some little movies on Twitter, if you find them, that showcase how bright Betelgeuse will be. And it will be a source of light pollution, I can tell you that. I mean, the night sky, it will be much brighter than the full moon. It's going to be, you will be able to read a newspaper under Betelgeuse in the night sky.
So what would happen to Orion then? Would that also become completely wiped? Wiped?
Yeah, we won't be able to see anything. It will be like the other stars of Orion will look like, fireflies right next to a big spotlight. We won't be able to see much. So our night sky will be different for a couple of years.
Two moons in the sky. I mean, when we have a full moon, if that would be like, well, from different locations, I guess.
2 moons in the sky.
Does the moon ever goes into Orion? trying to remember my astronomy.
I
don't
don't
remember.
think it does get all that. It gets into Taurus.
Close-ish. Yeah.
Does it? Oh, okay. I'm trying to remember.
Yeah.
Is there any object that we can say during our lifetime as we speak, so this century, let's say, has changed dramatically?
Yes. The question is which one, right?
Yeah.
Well, there are different types of variable stars whose brightness is changing. And there are some that explode in a non-catastrophic way that are called novae. So our observers have been observing nova eruptions for tens of years now, and they're working with professional astronomers alongside trying to understand what the physics behind an nova eruption is, using actually not only our ground-based observations, but also space-based observations. So these are pretty much stellar indigestions, where one star is trying to cannibalize its companion. It can't handle the material on its atmosphere, and then it throws it up. Here's a disgusting analogy for you. But it's we do see this kind of phenomena within the variable star world. Again, we can't predict a supernova, which is a complete catastrophe of the star. And we don't have models that are accurate enough to point towards a specific source and say this is going to become a supernova tomorrow within our own little lifetime. We can make the predictions within, again, hundreds of thousands of years, which is not helping anyone. But this is what we have. And that's why we keep observing. We keep trying to capture this kind of phenomena and understand where they come from.
Would it be a possibility that with the advancement in technology, that we could narrow this the range of what the prediction accuracy on when a star would go supernova?
Those predictions are based on data. So technology itself by itself is not going to help you. What's going to help you is you get more data. You try to understand the underlying physics, and then you study the rest of the universe. You say, okay, based on what we understand, this star and this star and this star will do A, B, or C. But having said that, again, everything is based on data, on observations. And it's not only for supernova eruptions, right? It's for planet formation. It is for eclipsing binaries. It is for pulsating variables. It is for stellar atmospheres. It's for dark matter, dark energy. I mean, anything and everything we have in astronomy, including our solar system, how the sun works. And we've been observing this star through a telescope for 400 years now, right? Galileo was the first one who discovered spots, and we still don't understand the details of its cycles. Right. So it's things like that, trying to understand our universe. This is where astronomers come in.
Your instruments and observatories can only do so much. Once you have observed, then there's pretty much from the engineering standpoint, you've exhausted what you can do, right? I guess you have to look at the pattern, the empirical pattern. That's what's going to tell us the history, I guess.
You have to look at the pattern. That's very true. The interesting thing with astronomy is that it drives technology evolution very frequently. I mean, just think about it. Wi-Fi was discovered by astronomers when they wanted to just transfer their data, big data sets. So when it comes to trying to understand the universe, not just the pure science part that is driving progress, it's also the need of the community to actually do more and look at the universe in a different way that is actually driving technology as well. That's why astronomy has always been at the forefront of technological advancement. And that's why it's really very important and very applicable to our everyday life to actually keep asking questions, although most of the time we're not asking the right questions. But keep asking questions. We're getting towards the right direction, and try to build the technology that we need to answer them, because those technological applications are pretty much the seeds of what we have every day in our disposal, right?
Right. And now, your organization contributes a lot to that data, as we've already talked about a little bit. Can you give us an overview of sort of how someone who's maybe got some skills as an astronomer, has a modest sized telescope or some other type of equipment, can make that contribution, actually become a citizen scientist like that?
Absolutely. And actually, I can tell you how someone who has absolutely nothing in their disposal, they're just barely interested to get started, can actually get started. Because
Okay.
actually, our organization prides of taking citizens who are interested from zero to contributing observations. We have a lot of training material for observers, from manuals to online courses to mentoring to workshop to a very active help desk to help individuals understand how to make contributions in terms of observing variable stars with whatever means they have. They may have just a DSLR camera, one of those cameras that you use.
Yeah, I've
In
got
order
two or three of them.
Yeah, there you go. Take pictures of flowers and of trees and of your family during
Yeah.
vacation. You can definitely use it to take data, astronomical data. We have observing sections that have very up-to-date information on different types of variable stars. So you will learn a little bit more what they are, why they're important, how they work, what a light curve is to begin with, right? Which is our main tool to study the night sky. And by the way, a light curve is simply a recording of a brightness variation with time. That's all there is. It's the same thing as if you have kids and you're recording their height with time, right?
Right.
That's what we do with stars, record their brightness with time. That's all we are recording. We also we are the ones who are actually recommending different targets of interest because there are billion stars in the night sky. How do you know which one is interesting? And we have different ways of actually communicating that to our observer community, depending on where they are on the planet and what kind of means they have in their hands. We have software for data analysis and reduction. We have lots of individuals who want to do their own projects. And these are from your next door neighbor who wants a project for their retirement, to a teacher who wants projects for her students, to a professor who wants projects for her students, to a student who wants projects for their own astronomy club, for a science fair or something like that, to, of course, anyone who's interested in analyzing data themselves. We also have a journal that publishes scientific outcomes. This is a refereed journal. So it is a journal that is actually priding of publishing correct science, and it's open to anyone. You don't have to be a professor at the university. You don't have to be connected with a research institute to publish there. We are doing data quality control. One of the things that we found is that even the most experienced observer occasionally can submit discrepant data, and it has nothing to do with the observer. It may have to do with the software they're using, some glitch in the software, some glitch in the software for their telescopes, something is recorded wrong. Things happen, right? Especially in the technology world. So we make sure that the data that are being submitted to our databases are being checked. And of course, we are maintaining the databases. So other than the photometry database, now we have a new spectroscopy database. We have an exoplanet database for exoplanet follow-up. We have the variable star index. It's a super catalog of information on variable stars. We have lots of databases like that. So this is something that is a resource for those who want to learn a little bit more about variable stars, see what kind of data exists. So going back to your beginning, if somebody wants to get started, all they need to do is contact us, avso@avso.org. We are there to help. And we can provide targets for beginners and targets for intermediate observers and targets for advanced observers. And let me actually say that Betelgeuse is a target for advanced observers. It's a difficult object to observe, believe it or not, because it's too bright.
Ah, yes.
It's one of those interesting stars that professional astronomers can't observe simply because it's too bright for big telescopes. And non-professional astronomers, our observers, need to be careful when they're observing it because the comparison stars are tricky.
I see. Yeah.
It's almost counterintuitive because one would think that, something that is so popular, it's so visible at the naked eye, it would be, easier. But in reality, it's quite the opposite, I guess, right?
Yeah, it's extremely difficult. And if not anything else, this is an example where small telescope, DSLR cameras, even photoelectric photometers that don't really exist anymore, but they're being maintained by some of our observers, make very unique contributions to science. You can't observe Betelgeuse any other way. If you have a big telescope, by the time you open the shutter, it saturates. Forget about it. You have to actually play games with special filters or defocusing, or you're wasting your big telescope time trying to observe Betelgeuse. So our observers with their small telescopes and spectrographs, with their DSLR cameras, are making very unique contributions trying to understand this phenomenon. This is what actually makes me very proud about these individuals. They're doing their best and they're providing very unique data sets here.
Can I just go back for a moment to the supernova possibility?
Yes.
Should this happen during our lifetime? So what would be the clues, the really clear clues that this is happening? How would people be able to experience these events in real time? So how many days or weeks or months or, I don't know, years, whatever will that take? How do we witness this amazing event visually?
There's one telltale, I guess, right before a star becomes a visual supernova source, and that is neutrino detection that emerges from the inside of the stars. It reaches the final decay processes to reach iron. But what we're going to see is something, depending on whether it's nighttime or daytime, right? If this happens during your nighttime, you will see a star that is actually a nice little red dot, kind of brightening, and then becoming really bright. So depending on your perception, please don't think it's a UFO. It's not a UFO. It's just a beautiful phenomenon that's happening in your night sky. And it's very identified. And it's not flying anywhere. If you are in a daytime and suddenly night comes, you will see something extremely bright polluting your night sky, like a big, big spotlight in your night sky, and wondering what it is. So let's see. So I have a question for you guys.
Okay.
What do you think will be the reaction of people after supernova goes kaboom, after Betelgeuse goes kaboom?
Obviously, aliens.
Oh.
Well, yeah, obviously, but besides that, well, I think that of course everybody will want to go out and see it, but the most I can just imagine the headlines now, and people will be worried about the end of the world, and the gods are angry with us, but by and large, I think it'll be similar to an eclipse in the sense to the public interest and how people will respond. Of course, we can predict the eclipse. They can plan years ahead of time, but for this, it will just be, all you have to do is step outside, assuming it's the right time of year. You may have to get up early in the morning or to see it, but depending on time of year.
It's kind of interesting. Sorry for interrupting, Paul. It was kind of interesting because talking about all this, because I would actually, seriously speaking, I wonder if there are certain population in more isolated places on Earth where there's no much in terms of communication and access to scientific information, where maybe some tribes, some populations might really not understand this phenomenon and really panic to a certain extent, or at the minimum give some theological explanation to it. I mean, I'm not saying it's be widespread panic, but there might be some pockets here and there where it's possible, I would think.
But even in our Western civilization, there might be some accounts, written accounts or paintings that maybe testify of some previous supernova explosions. Are you aware of any of those, or even in indigenous artworks, for example? There might be some examples that show already something happened in the past.
Yes.
Well, I'm thinking when a rocket not explodes. What I'm thinking about yesterday. That's why I said explode. But when a rocket, even sometimes some of the more spectacular launches that happen in the morning, and you see that I've seen story of people that don't understand that that's a rocket launch, starting to make all kind of speculation, even for something as popularly known as a rocket launch. There's schedules everywhere, there's news and information everywhere. There's still some people, and I'm not talking about in some isolated island in the middle of the Pacific, but I'm talking about people in the United States that literally don't know what happened, and they say, wow, what's that? What is it, a UFO? Is it some other phenomenon?
Oh yeah, they'll.
Or,
I'm sure there'll be every possible combination of
I
those
wouldn't be
things.
surprised if some people don't not understanding what's happening.
Or there could be panic because they think the Earth is threatened by this
Right,
supernova. But
right.
now, if it were closer, it would be a threat.
If it were closer, it would be a threat. I think that this is the value of discussions like the one that we're having right now,
Yeah.
popularizing science and answering people's questions like, what will happen if Betelgeuse go kaboom? Will it be dangerous? The answer is no. It won't be dangerous. It will be bright. It will be pretty or ugly, whatever your preference is about a light source in the night sky, but it won't affect the Earth. It won't affect our atmosphere. It won't cause mutation. Radiation is not going to hit us and kill us or anything like that. So having active discussions around this kind of phenomena and try to explain to as many people as possible what they are, what the ramifications, quote unquote, are for life here on Earth, and how pretty they're going to be, and how excited we should be to be able to witness something like that, because it's a once in anyone's lifetime phenomenon, right? We're going to be part of history if you think about it. It's really very important. So when you're talking about the outcomes of explosions that don't have, that panic people, I think that more information is needed, as simple as that, so that people demystify things like that.
Information and education. That's so
Information education. Again, this is the value of citizen science in general. You engage citizens to what you're doing so that they don't think it's magic to begin with. And actually, the power of citizen science is also the fact that without those citizens, without those individuals, we cannot do this kind of science. So you have a group of really highly educated, very motivated, excited individuals helping professional astronomers, being collaborators to science.
How can we remove this entire halo of how can I put it? There's a halo of inaccessibility, of dryness that the common man that sees in the scientific community. There's a lot of let's face it. There's a lot of skepticism. There's a lot of lack of trust, not from people like us, that understand and follow science on a daily basis and work in the scientific with the scientific community. But there's a lot of people out there that still see that have difficulties even being able to approach. You know what I'm getting at. So, what do you think could be some of the ways that we can try to make science more accessible to people that still perceive science as something dangerous, something scary? I don't know.
I think that we all perceive something as scary or inaccessible when we don't know about it. It's exactly what you said. The reason why Betelgeuse is not something magic for me and you is because I know some basics about that star, right? But if you show me something I do not understand and it's very close to my home and I will see it as a threat, then I will be scared about it. And it doesn't really matter if I'm a scientist or not. It matters that I just don't know anything about it. So I think, again, that popularizing, discussing, putting science in front of individuals. People are smart. That's why we've evolved to be on this planet and do what we're doing. If you bring information in front of individuals and have the patience to translate it in a way that everybody will understand, then you will have a very powerful support group around you, understanding and discussing science. It's really exciting. It's like a big party. I think that scientists for a long time were considered to be a very exclusive group of individuals who speak a different language, completely different jargon. And I think that if not anything else, this century, things have changed. Scientists are much more open to discussing their results. They realize that, everything that we do is taxpayer funded. So everyone has the right to to participate, and it's our obligation to translate it in ways that people can understand. And it's becoming more and more prominent, especially within the scientific community, to make an effort to explain to people that, yeah, we have gravitational wave detection and it's a smashing of two neutron stars, right? Yeah, we have Betelgeuse dimming, but there's nothing magic about it. There are possibilities it will become a supernova, but not because of this particular phenomena. This dimming might be these two cycles overlapping. So and more scientists being willing to discuss in podcasts and social media. So I think that it's just a matter of information, nothing else. And, think about, I am Greek, so I come from a background that has a long history of connecting science with paranormal phenomena back in antiquity, right? The gods are not happy with us, so they're taking the moon away. Here's a lunar eclipse. So when people demystified that, it became a phenomenon that everybody enjoyed, right? Nothing to be afraid of. So I think that we are on the right track. As simple as that. I'm very optimistic.
Important also to have, correct me if I'm wrong, of course, from your expert standpoint, it's important also for a lot of people to see the connection to the day-to-day life, because a lot of people perhaps think, how does this affect me on a daily basis? And without necessarily seeing that, understanding the universe, understanding what happens in the universe, it's also important to understand how we can, go day to day in our lives. I think that in a way, everything is connected together, and our understanding in the universe gives us also a meaning to understand our own lives. I mean, that's for me, and I cannot speak for everyone, but I guess some people don't see that connection. Maybe necessarily they don't. I don't know. Maybe that's one explanation that I have why some people are maybe perhaps turned off a little more than others. I don't know.
Yes, and I think that it is our responsibility as scientists to actually make this connection for people, not expect them to understand just cause. So again, keep the discussion open, keep the questions open. I don't know if you have any questions from your audience right now, Paul. So I don't want to
not yet. No. I'll allow a few more minutes for questions. But this is like I just said, this is our first live question session, and it's a work day for a lot of people. So I'm not surprised we don't have a big audience. But if there's anybody out there who has a question, you can. I'll even take it on YouTube, or Discord or Twitter at Podcast Wow.
Can I just rephrase the question from earlier? Because you said that there are indeed some examples from artworks from the past testifying about some astronomical events like a supernova explosion that reached us. Is that so? Is that the case?
Say it again, please.
So we were talking earlier about what if other generations before ours experienced such an event as a supernova explosions or some astronomical event that they could not explain scientifically or in any other way, but other than mythology, for example, or which I still find really fascinating, by the way. So I'd be curious to hear what you know about this, because you just say that there are such examples.
Right. So there are, in human recorded history, there have been mentions of bizarre phenomena, right? Novae have been recorded by the ancient Chinese for the first time as a new star. Algol as a binary star system is being mentioned in the Cairo calendar, ancient Egypt, as something that has a periodicity of 2.8 days. So ancient Egyptians 3,000 years ago knew that there was a binary, so a thing. They didn't necessarily know it was a binary. And ancient Chinese didn't necessarily know that it was a nova, or a supernova, whatever bright star. As you mentioned, there are lots of indications from paintings of celestial phenomena that just left an impression with the artist and somehow made into their painting. So we see things that look like comets, for example, that are not recorded in human history. It's 12th and 16th century paintings. I can't give you specific examples right now because I can't bring them off the top of my head. But what I know is that this kind of phenomena always fascinated people, and they somehow incorporated them in their culture, somehow incorporated them in their written culture when they could. And even those petroglyphs occasionally showcasing things with rays and tails, that look like, I don't know, stars, or they look like exploding stars, that you find occasionally may be actually depictions of this kind of experiences. We can't we can't date them accurately, so that we can't go back and trace them. But occasionally there have been connections of supernova, for example, with their remnants, right? Kepler's supernova. There have been records from 500 years ago that go back and point to the nebula that we see now. So it will be very interesting to see if anyone has made like a concentrated effort to record all these phenomena and, talk about ancient transient sky astronomy and present it to the public. I would be very interested to read a paper like that or a book like that, if it exists. So let me know if you find one.
Okay.
I have a question, please, for Stella. Talking about variable stars in general, and of course, I'm not an expert by any stretch of imagination. As a matter of fact, knowing that we were going to be on the show today, I went and spent half an hour on Wikipedia yesterday, and I noticed one of the things that struck me was how many different types, how vast is the field of types of variable stars, right? We have so many different types of variable stars, and what it seemed to have occurred to me, and one of my questions that came up was, it seemed almost like, to me, almost seems like every star is variable to one degree or another, and it seemed to me that variability is more a matter of degree, right? Than so I guess coming to my question is, there are stars that are not classified as variable, to my understanding. They're I don't know, I guess constant star is the right term. So what is the I don't know if I'm formulating the question correctly or not, but what would be the threshold? What would be the defining factor? What are the metrics to classify a star as variable or non-variable?
It's an excellent question. A star in our nomenclature, in our world, is variable as long as you can observe variability from the ground, from here, from the Earth. Even with space-based, one of the things that we learned from the Kepler mission is that to a point, every single star in the night sky can be changing with time. So variability, as far as we're concerned here at the AAVSO and most astronomy, right, is something that you can detect, where you can detect a change in the brightness of the star from the ground. Now, something, as you mentioned, something is variable with respect to something else that is constant. How do you define a constant star? You have to remember our detection abilities are not infinite. We can't, from the ground, we cannot measure change in the brightness of the star down to millimagnitudes, simply because of our technology limitations. So if the accuracy with which you can observe a star's brightness is 1/100th of the magnitude, right, then everything under that is noise. So then everything that is variable, that is changing in brightness within, for more than 1/100th of a magnitude, is variable, right? And of course, it depends on what kind of means you're using. Excuse me. If you're using your eyes, our eyes are less sensitive than a digital image that you can stretch and you can play with. So with your eyes, you can detect variability typically down to 1/10th of a magnitude. Right? I have some very, very talented observers who actually can detect variability with their eyes and a big telescope down to to actually 5% of a magnitude, which is like blows my mind. These
Very
are
good,
people who
yes.
are super talented. They're not professional astronomers. They're amazing individuals who can actually do that, and they've been doing that for decades, right? Detect variability of this kind of stars and provide all the excellent data that we have. But for a person like me who has tried to do visual observations, a tenth of a magnitude is considered to be a big success. Yay, go me! If you have a DSLR camera or a CCD camera, if you have more digital means, then you can do measurements a little bit more accurately, but you have to remember that you have to process your data and remove the electronic noise of your instruments, right? And even the read noise of your instrument, all kinds of noise sources that come from the observing process, and that is introducing your error bar. That is telling you how detailed your measurement can be. So yeah, although every single star in the night sky theoretically has some level of variability, doesn't really mean we can observe them from the Earth.
Right.
Also, a star is constant until it starts doing something. So there have been instances where we're using constant stars as comparison stars, where we have been using certain constant stars for decades, and suddenly one of those starts doing something that is way above the noise. You're like, oh, okay, then I guess you're not a constant star anymore. So these are the most challenging cases because we have to go back and calibrate all the light curves and all the data that have been submitted using that particular star as a constant star. But now I'm getting into details. Did I answer your question?
Yes, definitely answered my question. I really appreciate that. That's it's very fascinating.
It is, isn't it?
It is it's a difficult thing because really the way you measure brightness of a star is by comparing it to stars that don't vary in brightness, right?
Hmm?
And that have been carefully calibrated.
Yes.
Now, we should mention that something like the Kepler Space Telescope measured brightness down to exquisitely low noise levels, but you have to be in space with a very expensive instrument to do that.
Yeah, and you have this thing here that is called the Earth's atmosphere that, for better or worse, is messing up with our observations, but it's a blessing for humankind, right?
Right.
Otherwise, we wouldn't be able to be here and breathe and have this discussion. So at some point, you are, again, it's a comparative science.
Right.
And we're trying to actually do the best with the means that we have in our hands.
Right. Well, I think you guys do a wonderful job. And I look at your data almost every day. And,
Me too.
and by the way, I should let the audience know that Stella was on about 3.5 years ago on the podcast to talk about Boyajian star, which we called Tabby star at the time, and what her team was doing to monitor that. They still are monitoring that star. Although right now, this time of year, it's a really bad time of year to be looking at it, and only people way up north can see it. But I just checked this morning, and there was more data from Belgium, which is, pretty far north. But anyway, thanks a lot, Stella. The hour has flown by, and we appreciate it. And you have the honor of being our very first Wow Signal Live guest.
Wonderful.
We've been doing all these pre-recorded before. Now, I will take the audio from this and make it into an audio podcast, and I will let you know when that's available. It should be a day or two.
Sounds great.
And so I'd like to also thank Daniela.
Thank you, Paul. Thank you to everyone for the really interesting conversation. I've learned a lot. Thanks.
And Chiro.
Thank you, Paul. It was a pleasure to meet Stella, and a pleasure to see Daniela again, of course.
Now, I think this is actually officially the first time Chiro's been on the Wow Signal.
Yeah, I think so.
But he was on the Unseen podcast.
Yeah. That's right. That's why nobody saw us, but Paul, because it was unseen. You know what I
mean? Yeah. Well, the Unseen podcast was our spinoff for about 3 years that we did, and that's how I came across Chiro, and he was on that many times, and so welcome to the Wow Signal.
Thank you,
and hope to have you back.
Pleasure. My
And
honor.
so anyway,
So, can I say one last thing?
sure.
The Betelgeuse light curve is evolving. Every day, our observers are submitting new data. So, if any of your audience, anyone from your audience wants to keep following it and even look at it through the AVSO observers, www.avso.org, you can actually plot a light curve and see what it's doing every day.
Yeah, and
There.
I do that, and I can tell you it's very easy.
Mhm.
And you just type in Beetlejuice. If you don't spell it wrong, it'll come. You'll get the light curve.
Or Alpha Orionis, brightest
Alpha Orionis, yes.
Alpha
Okay.
Ori, yeah. So you can
Okay.
do either or.
Yeah, and if you were interested in working with Stella's organization to become a variable star observer, go to the same website, aavso.org, and
Absolutely. And you
they'll
can
set you up.
actually become a member. It's only $85 a year, and you're supporting a great citizen science organization. Or you
Yeah.
can just, if you have any questions, AVSO at avso.org, just send us an email.
Yeah, and
Simple as that. We're
you
here.
can also adopt a star, right?
And adopt a star. Oh, you can adopt Betelgeuse.
Yeah, you can adopt any star you like that they observe, and
Yeah.
it's not $85 a year, something else, but it's
It's like $30.
$30 a year, and
Yeah.
it helps the organization, and it keeps the lights on at AAV. So,
Sounds
and
good.
anyway, thanks so much, Stella, and if we may have you back in a couple of years to tell us
Talk
about
about something else.
something else that's flickering in the sky. Okay,
Sounds
well,
good.
thank you so much, and
Thank you all.
thank you the rest of you, and this will conclude this live stream portion of our program. Thank you.
Bye, everyone.
Bye.
Okay.